Okay, now it's time for part 2 of our demonstration. So we demonstrated with the two dissimilar metals, we had a difference in electrical potential, and so what's going to happen is one of these metals is going to donate electrons to the other one. The metal that donates the electrons will corrode, and so we call that piece the anode. That'll be the steel. The other piece of metal that accepts the electrons is going to be the copper, because relatively speaking, copper is more noble. In other words, it's higher on the galvanic series than steel is. Now, if I put them both in the water just like that, they really won't corrode. So what we need to have is an electrically conductive path between the two of them. So I'm going to take this jumper wire, and I'm going to connect the jumper wire first to the copper, and then I'm going to connect the jumper wire to the little piece of steel. Okay, and now they are electrically coupled. But again, corrosion won't take place because we also need to have an electrolyte. The electrolyte is the water that's in the little jar. Okay, so once they are immersed, the iron or the steel is going to send electrons through the little wire into the copper, and that is going to lead to galvanic corrosion. So I don't have a meter hooked up. You can't actually see the electrons flowing, but what I will do is over the next few hours I'll take a few screenshots, and we'll do sort of like a time delay thing, and you can actually see we'll take a long time period and sort of compress it into a very short time period.